Maximum sum sub-array problem. Let us first understand what is this problem. Suppose that we have a given array of 8 elements starting from index.
सब array बनेगा नहीं, तो मेरे को stop यानी कहाँ प्रॉब्लम आती है? लेकिन उनमें से जो आज की इस वीडियो में एक्सप्लेन करने जा रहा हूं वो कौन सी प्रॉब्लम है? मैक्सिमम सम फाइंड आउट करना है, मतलब मैक्सिमम जो एडी सब एरे के हिसाब से। अब देखो पहले तो प्रॉब्लम को समझो एक्चुअल में है क्या, क्योंकि सोल्यूशन तो बात की बात है यार। पहले प्रॉब्लम को समझो, दिमाग लगाओ, लॉजिक लगाओ, उसके बाद जो है वो आप कोड समझो। अब देखो सबसे पहले लेट्स से मेरे पास एक एरे दिया हुआ है ए। अब उस एरे में टोटल 7 एलिमेंट्स है। लेंथ ऑफ द एरे कितना है? 7 है। तो मेरा इंडेक्स जो है वो 0 से स्टार्ट होता है, तो 0 1 2 3 4 5 6। तो इस तरीके से मैंने एरे में अपना एक और चीज क्या गिवन है, सब एरे का साइज। मुझे लेट से एक सब एरे का साइज W जो है वो 4 गिवन है, कि मेरे को जो एक सब एरे लेना है उसका साइज कितना 4। अब सब एरे क्या होता है? एक तरह से सबसेट है यार, किसी बड़ी चीज का छोटा सा सबसेट। वही यहाँ पे है, एरे का छोटा सा एक पार्ट लेना है। अब यहाँ पे मेरे को दे दिया कि जो सब एरे है, जो छोटा पार्ट ले रहे हो वो 4 साइज का होना चाहिए। तो अगर मैं 4 साइज का बनाऊं, तो मैं अगर स्टार्टिंग 0 से करूं, तो 0 से मैं 4 का 1 2 3 और 4, यानी ये मेरा एक सब एरे हो गया, जिसको मैं नाम दे सकता हूं S1, जो कि मेरा एक सब एरे। ठीक है, अब इस सब एरे का सम फाइंड आउट करना है, क्योंकि मेरे को गिवन है, ये चीज गिवन है। आपको 3 भी दे सकते हैं, 5 2 जो मर्जी दे दे। तो आपको उस हिसाब से यहाँ पे S1 मेरा टोटल जो है वो कैलकुलेट करो। तो वो क्या कहता है, 8 और 3 11 13 14। ठीक है, और ये हो गया जो 8 और 3 11 13 और 5 कितने हो गए 18। तो यानी S1 का टोटल कितना है? 18 है। ठीक है, तो ये मेरा इस तरीके से कैलकुलेट करना है सब एरे का टोटल सम। तो कैलकुलेट कर लिया। अब उसके अप्रोच कह देते हैं वो बता रहा हूं, और नेक्स्ट वीडियो में हम लोग बात करेंगे जो इसके लिए सबसे ज्यादा यूज की जाती है, स्लाइडिंग विंडो मेथड। लेकिन स्लाइडिंग विंडो मेथड क्यों आया, क्यों नहीं करते, ये वो सारी चीजें पहले आपको बेसिक मेथड पता होना चाहिए। क्योंकि इंटरव्यूज में, कॉम्पिटिटिव एग्जाम में, कहीं पे भी आप जाते हो तो यार वो बोलेगा कि स्लाइडिंग विंडो बता, आपने बता दी, रट्टा मारा हुआ था बता, वो बोलेगा भैया पहले क्या था। अब पहले तो सर पता नहीं जी क्या था, तो क्यों आई भैया, तो पहले वाली अप्रोच ही लगा लेता। तो मुझे पता होना चाहिए पहले वाली अप्रोच क्या थी, उसके अंदर क्या प्रॉब्लम थी, क्या टाइम कॉम्प्लेक्सिटी, ये सब फिर हम नेक्स्ट में देंगे। तो इसलिए पहले बेस बनाना बहुत जरूरी, इसलिए बेसिक अप्रोच यहाँ पे बता रहा हूँ। और उस अप्रोच में हमने करना क्या, आप खुद ही थोड़ा सा सोचो कि ठीक है हमें प्रॉब्लम तो समझ में आ गई। अब मुझे यहाँ पे बहुत सारे चैलेंजेस आ रहे हैं, लेकिन उनमें से जो सबसे पहले एक चैलेंज क्या कहता है कि यार मेरे को एक्चुअल में जो सब एरे इस तरीके से चलते जा रहे हैं, पहले हमने यहाँ से यहाँ तक किया, फिर हमने यहाँ से यहाँ तक किया, फिर हमने यहाँ से यहाँ तक बनाया, फिर हमने यहाँ से यहाँ तक बनाया। इसके बाद कोई और सब एरे बनेगा नहीं, इसके अलावा कोई और 4 साइज का तो सब एरे बनेगा नहीं। तो मेरे को स्टॉप यानी कहां पे करना है, मेरे को यहां पे स्टॉप करना है, इस पॉइंट पे मेरे को क्या करना है, स्टॉप करना है। यानी आपको हमेशा किस पॉइंट पे स्टॉप करना है। अगर मैं लेट्स सपोज 3 का ले लेता, तो यानी आप 3 यहां पे बनाते, फिर आप यहां पे बनाते, फिर आप यहां पे बनाते, और इस तरीके से करते करते लास्ट आपका ये होता, और फिर आप यहां पे स्टॉप करते। इससे आगे तो जा नहीं सकते, क्योंकि 3 का अगर बना रहे हो तो ऑब्वियसली अगर नेक्स्ट शिफ्ट करोगे तो 2 रह जाएंगे एलिमेंट, नेक्स्ट तो है ही नहीं, यानी यहां पे स्टॉप करना पड़ता। तो एक तरह से खुद ही थोड़ा सा सोचो आप किस एलिमेंट पे स्टॉप कर रहे हो। 4 का केस था तो 3 पे स्टॉप कर रहे हो, अगर 3 का केस होता तो आप इंडेक्स नंबर 4 पे स्टॉप करो। और ये कैसे निकल के आ रहा है, व्हाट इज द लेंथ ऑफ द टोटल एरे। टोटल लेंथ कितनी एरे की, टोटल है जी आपकी 7 माइनस विंडो का साइज कितना है आपका, विंडो का का साइज है 4, यानी क्या आया 3, यानी आपको इस इंडेक्स पे स्टॉप करना है। अगर मैं 3 का एक सब एरे बनाऊं तो टोटल साइज कितना एरे का 7, और मेरा जो विंडो का साइज एक तरह से कह लो या एक तरह से जो सब एरे है उसका साइज कितना है जी 3, और क्या आंसर है 4, तो फिर आपको इंडेक्स नंबर 4 पे स्टॉप करना है। तो ये इस तरीके से लॉजिकली अगर सोचोगे उसके बाद आप थोड़ा थोड़ा कोडिंग जो है वो करना स्टार्ट करो, इसीलिए पहले लॉजिक को बिल्ड किया करो। और उसके बाद अब हमें पता है कि यार मेरे को पहले 4 ये इस तरीके से, अगर मैं पहले सब एरे की बात करूं, इस सब एरे में मेरे को यहां पे सारे एलिमेंट्स को एक एक करके जोड़ना है। तो यानी एक लूप तो आपका पहले चलेगा जो पहले इन जो एक तरह से सब एरेज को ध्यान में रखेगा, और दूसरा लूप चलेगा जो इस सब एरे के अंदर एलिमेंट्स के ऊपर चल के और सारे एलिमेंट्स को जोड़ेगा। और वही चीज हमने यहां पे किया। हमने क्या किया, सबसे पहले हमने एक यहाँ पे वेरिएबल ले लिया जिसका नाम रख दिया हमने मैक्सिमम, जो कि सबसे मैक्सिमम वाला जो आंसर है वो फाइंड आउट करके बताएगा। और मैक्सिमम हमने इन्हीं से, आप चाहे स्मॉलेस्ट वैल्यू, अब कईयों के दिमाग में आता है सर -10 ले लेते हैं, अरे भैया सम कर रहे हैं तो हो सकता है ये वैल्यूज हमेशा प्लस में थोड़ी ना होंगी, आपको माइनस में भी दे सकते हैं, आपको माइनस में 12 दे दे, माइनस में कुछ भी दे दे। तो इस तरीके से अगर वैल्यूज दे दें तो भैया ये तो आपको गड़बड़ा जाएगा। तो इसलिए छोटी वैल्यू लो, लेकिन छोटी माइनस इनफिनिटी से छोटी क्या है, कुछ भी नहीं है, तो इसलिए इसको इनिशियलाइज कर दिया हमने माइनस इनफिनिटी से। उसके बाद फॉर i इज इक्वल टू 0 टू लेंथ ऑफ एरे माइनस w, जो मैंने अभी बताया, जो कि आपका पहले ये वाला सब एरे, फिर ये वाला सब एरे, फिर उसके बाद ये वाला, और फाइनली ये वाला सब एरे पे स्टॉप कर जाएगा। और उसके लिए हमने ith जो है वो एक मेरा यहाँ पे मैंने इस तरीके से लूप चलाया जो i इज इक्वल टू 0 से लेके अगेन भाई लेंथ ऑफ द एरे कितना है हमारे पास 7 माइनस 4 विच इज द सब एरे साइज, तो टोटल मेरा 3, यानी 0 से लेके 1 2 3 तक चलेगा, क्योंकि इसके आगे तो कोई सब एरे बनेगा ही। तो यानी ये मेरा लूप जो है वो इसका ध्यान रखेगा कि मेरे को इसके इस तरीके से सब एरे लेने। उसके बाद मैंने क्या किया, एक और वेरिएबल ले लिया मैंने करंट, और करंट को इनिशियलाइज कर दिया मैंने 0 से। वो एक्चुअल में करंट इसका नाम क्यों रखा है कि जो एट प्रेजेंट जो करंटली मेरी जो विंडो है, करंटली जो मेरा सब एरे है, उस सब एरे का टोटल जो है वो करंट में होगा। तो नेक्स्ट टाइम नया विंडो बनेगा, नया सब एरे बनेगा, उसका साइज उसका सम रखेगा, फिर इस तरीके से जो है वो करंट हमेशा करंट जो आपका सब एरे है उसका जो टोटल सम है उसको कंटेन करके बैठा है। देन लो जी, फॉर j इज इक्वल टू i टू i प्लस w माइनस 1। अब हमारे पास जो एक लूप हमने चलाया अब अंदर j, और इस j की रिस्पांसिबिलिटी क्या है, जब मेरा i जो है वो कहां से लेके यहां तक चल रहा है, हमने क्या करना है, इस i के अंदर ये वाला जो सब एरिया उसके अंदर मुझे जो है वो इनका सम फाइंड आउट करना है। और ये जो j है ये कब तक चलेगा, 0 से, जहां से मेरा i है वहां से स्टार्ट करे, लेकिन रुके कहां पे, जो मेरा w तक। कितना तक रुके, जो w मेरा टोटल कितना है जी आपका 4 है, तो यानी 4 से ज्यादा एलिमेंट लेना जाए, तो हर बार ये इस तरीके से चले। तो कैसे चलेगा, i j इज इक्वल टू i जहां पे आपका i है वहीं से हमारा j चलेगा, लेकिन कब तक चलेगा ये बड़ा इंपॉर्टेंट है जी, i प्लस w माइनस 1, मतलब पहली बार की बात करूं तो 0 प्लस 4 माइनस 1 विच इज 3, देख लो जी 0 1 2 3, तो यानी यहां तक चलेगा। और यही हम चाहते हैं, जब हम 1 पे पहुंचेंगे तो 1 से लेके वो यहां तक चलना चाहिए। तो फिर i इज इक्वल टू 1, तो यहां पे उस केस में क्या होगा, जब i मेरा 1 पे होगा तो j मेरा 1 से लेके कहां तक चलेगा, 1 प्लस w कितना है 4 माइनस 1, क्योंकि w तो मेरा विंडो का साइज कह लो या सब एरे का साइज विच इज फिक्स, तो यानी फिर उस केस में 1 से लेके 4 तक। तो वही हम चाहते हैं कि नेक्स्ट में वो 1 से लेके 4 तक चले। ये चीज हमें इस तरीके से लॉजिकली बिल्ड करनी पड़ती है। अब देख लो जी, उसके बाद हमने क्या किया, j के अंदर, j वाले लूप के अंदर करंट इज इक्वल टू करंट प्लस प्रेजेंट एलिमेंट का सम। अब करंट मेरा इनिशियली क्या है 0, तो मेरा यहां j से चलना स्टार्ट करो, ये कहां तक चलेगा, आपका यहां तक चलेगा। तो सबसे पहले 0 प्लस 3 होगा, फिर j इंक्रीमेंट हुआ, j करंट, देखिए ये एक्चुअल तरीके से आपका प्लस 6 क्या हो गया जी आपका 20। तो इस तरीके से आपका j जो है वो पूरा लास्ट तक चलेगा, और फाइनली करंट कितना हो गया 20। फिर भाई 20 आपका करंट है, और मैक्स कितना है जी आपका, मैक्स है यहां से लेके 6 तक चलेगा। दो भी दे सकते हैं, तीन भी दे सकते हैं, चार। तो लेंथ ऑफ द एरिया अगर n एलिमेंट्स है तो हमारे इस एग्जांपल में हमने j लगाया, n/2 से ज्यादा भी चल सकता है वर्स्ट केस में तो आपका। तो इसीलिए आपकी जो W विंडो का साइज दो भी दे सकते हैं, तीन भी दे सकते हैं, चार। तो लेंथ ऑफ द एरिया अगर n एलिमेंट्स है तो n-2 या n-3 n-4 तक भी चले तब भी रहेगा तो वो n टाइम ही ना, अगर n की वैल्यू बहुत बड़ी है तो n टाइम्स आपका तकरीबन n टाइम्स आपका i चल रहा है। और हर एक वैल्यू के लिए j कितना चल रहा है, j आपका जो है वो i की वैल्यू से लेके i प्लस w-1। अब w जो है अगर मैं w बहुत बड़ा वैल्यू ले लूं, w अगर मैं लेट्स सपोज इस केस में 6 ले लूं तो भैया यानी एक तरफ आपका जो j है वो भी तकरीबन आपका जो है वो पूरी की पूरी वैल्यूज तक ही चल रहा है। जैसे हमारे इस एग्जांपल में हमने j जो है तकरीबन हाफ टाइम तक चलाएगा तो n/2 भी अगर चल रहा है तब भी n into n, ऑब्वियसली एक वैल्यू के लिए अगर n/2 चल रहा है, दो वैल्यू के लिए n/2, तीन वैल्यू के लिए n, तो यानी n वैल्यूज के लिए n/2 into n which is n square, तो यानी ऑर्डर ऑफ n square। और इससे ज्यादा ही हो सकती है, n/2 से कम नहीं चलेगा, n/2 से ज्यादा भी चल सकता है वर्स्ट केस में तो आपका। तो इसीलिए आपकी जो टाइम
Hi, our next
हाय एवरीवन, वेलकम टू कोडक्राफ्ट विद लकी। तो आज का हमारा टॉपिक है मैक्सिमम सबएरिज्म यूजिंग डिवाइड एंड कॉन्कर एल्गोरिथम। तो मैक्सिमम सबएरिज्म होता क्या? तो मैक्सिमम सबएरिज्म हमें एक एरे दिया रहेगा और हमें इसका सबसेट तो चाहिए। कोई भी एरे की सबसेट मतलब कोई भी, जैसे ये इसका सबसेट है, ये इसका सबसेट है, ये पूरा इसका सबसेट है, कोई भी मतलब जो कंटिन्यूस मेमोरी में से हम वैल्यूज़ को निकाल रहे हैं, मतलब कंटिन्यूस रहना चाहिए। ऐसा नहीं है कि हम एक एलिमेंट ये ले लें, एक एलिमेंट ये ले लें, एक एलिमेंट ये ले लें, एक सबसेट नहीं। तो ये हमारा सबसेट होता है। अब वो सबसेट्स में हमें ऐसे सबसेट देखने हैं जिसका सम मैक्सिमम। तो जैसे ये सबसेट है -2 -5, इसका सम है -7। कोई ये वाला सबसेट है, इसका सम है 1, तो इसका ये -7 से ज़्यादा है। और अगर ये देखें तो इसका सम है 6 -2 -3 1 और 5 भी लेते हैं 5, तो इसका सम हो गया हमारा 7। तो इस तरीके से हमें सबसेट के सम निकालना है और उसमें से मैक्सिमम हमें रिटर्न करना है। तो इसका ब्रूट फोर्स अप्रोच तो वही होगा कि हम बार मतलब I2 n इटरेट करें, फिर हम J2 मतलब 0 to n इटरेट करें और J में फिर से हम 0 to n इटरेट करें और सारे सबसेट निकाल ले और उनके सम निकाल ले और फिर बाद में उन्हें कंपेयर कर ले कि मैक्सिमम सम किसका है। तो ये इसके ब्रूट फोर्स अप्रोच हो गया। पर अगर डिवाइड एंड कॉन्कर से हम देखें तो हमें सबसे पहले इसका मीट निकालना होगा। तो इसका मीट ये है।
Okay, so now the problem that we will be looking at next is going to be the maximum subarray problem. So this is a totally different problem. It's not a sorting problem. The problem is the following. If you have an array like this, -1, 3, 4, -5, 9, -2. You are given an array and you are asked to find the subarray that has the maximum, the maximum sum. So the problem is to find a subarray that has the maximum sum. Of course, if all the elements were positive, the solution is trivial. What would that solution be?
Sum of all items.
Yeah, take all items. So there's no problem. It's going to be trivial if all of them were positive. But the problem will be interesting when you have a mix of positive and negative numbers. So in this case, by inspection here, what's the subarray that has the maximum sum?
9 plus 4.
9?
No, 9.
What about 3 plus 7 minus 5 plus 9?
Yeah.
How about this? So in this case, this is the maximum subarray. 3, 4, this is 7 minus 5 is 2 plus 9 is 11. Can you find a subarray that sums to with a sum greater than 11? I don't think so. But now the point is to figure out an algorithm for solving this problem. Now what would be a brute force algorithm for solving this problem?
At all combinations.
Brute force what are these combinations and what would be the running time? So yn squared. So describe the algorithm.
You have to run every combination of everything inside of it, basically. So you have to start the first one, and then store that, take the next two, store that, take the next three, store that, take the next four.
So when you say next one, what do you mean by one? Is it an index?
Yeah, you have to just index up until you go through all of them, then you have to find the first one and do this. You have to have two indexes.
Yeah.
Start 0 index.
So basically for 0, you try every end index. So running time. So it's going to be a triangle that will give you theta of n squared. So this is brute force, but we would like to find a more efficient algorithm using divide and conquer. So let's see if we can discover a more efficient algorithm using divide and conquer. So the first attempt should be what?
Break the array into subsets.
Yeah, just cut it in half, right? So we're trying a divide and conquer approach. So the first idea that comes to our mind is just splitting the array into two equal subarrays. Now, okay, if I split it into two equal subarrays, and if I find the maximum sum here, maximum left sum, and the maximum right sum, will that be sufficient to solve the problem?
No.
Why not? So what else do I need to consider in addition to the left sum and the right sum?
Center.
Yeah, so I need to consider the subarrays that cross the center. So basically, any subarray there are three possibilities for any subarray. It either belongs completely to the left subarray, or belongs completely to the right subarray, or crosses the center. Only three cases. Either it's entirely on the left, entirely on the right, or it crosses the center. Now, okay, I can find the maximum left and the maximum right recursively. But now, in order to find the maximum subarray that crosses the center line, can you think of an efficient algorithm for finding the maximum subarray that crosses the center line? So we need an efficient algorithm to find a maximum subarray that crosses the center line. Now, the good thing about finding a maximum subarray that crosses the center line is that we don't have to worry about two ends. We already know one end of each half of this subarray that will cross, or not each half, each division of this array that crosses the center line. So does this give you a hint? How can we find the maximum subarray that crosses the center line? Yes?
So if you find the maximum subarray for the right or the left, you know the
So where do we start from?
if you start from the left, you find-
Where from the left, from which index?
you can start from the minimum index that comprises that subarray.
I don't know it yet. I want to find it. I want to find it. We're trying to find it. So in this case, you're talking about index 1, but I don't know it yet. So,
Starting from the center.
well, starting from the center, yes. Because I know that the subarray that will cross the center line is going to consist of two pieces. One piece to the left of the center and one piece to the right of the center. And I know the end, one of the indices of each piece. So I know that this piece is going to start at this index, and this piece is going to start at this index. So I don't have to worry about finding two ends of these two subarrays. So I know that on the left, I'm going to start from the center, and I'm going to keep going left, right? And in going left, what should I do?
Yeah.
What should I do? Go left, and then what do on the way?
Add each other.
Compute the sum, and yeah, and keep track of the max. So I'm going left. So initially my sum is going to be 4. Then I go left, my sum is going to be 7. Then I have minus 1, my sum is 6. Right? Then 7, I just keep track of the maximum value that I get when I go from the center to the start of the array. Then I can do the same thing on the other side. So I can start from 3, and then my sum now is 3. I go this way, 3, this is minus 5. Then 9, minus 5 and 9, that's 4. Then I have minus 2, so my sum drops to 2. So you go right and you keep track of the sum, and the maximum sum that I encounter on the way is going to be 4. So I have to mark, in addition to keeping track of the sum, what else do I have to track? The index at which this sum is found. So while going from center to left, I have to keep track of the index, which is here index 1. I want to remember that at index 1, I found the best sum. Of course, initially the best sum is going to be here, which is 4. Then when I go to this point, I find a better sum, so I update the sum. Then when I go to this, the sum becomes worse, so I just don't update. Because I did not find something better, I found something worse. Okay? So on both sides, I just go from the center to the left, center to the right, and then find the maximum sum on the left and the maximum sum on the right. Then what should I do with them? Add them. Yes, I should add the two sums. But will that necessarily be the solution to the problem? No. What should I do?
Variable max.
Yeah. So I have to compare 3 different solutions. L is the maximum sum for a left subarray, maximum left, and maximum right, and maximum crossing. And the best of them is going to be the solution. The best of them is going to be the solution. Okay? So let's try to write some pseudocode, some high-level pseudocode. So maximum subarray, array P and R. So first I cut it in half. So I do Q equals P plus R divided by 2. Then I do max subarray of A and what? P and Q minus 1. And this will give me L. And then I call max subarray of A, Q plus 1, and R. And this will give me R. Then I call maximum crossing subarray of A, P, Q, and R. Then what do I do? The max of the three. Yeah. Then I return max of LRC. What did I miss? And what's the base case? If P equals R, what should I do? If you have an array of size 1, what's the maximum subarray? What's the... Yeah, it's just that value. Return A of P. Now, I'm not going to write the maximum crossing subarray. I will leave that as an exercise for you. So this is left as an exercise for you. So this is the algorithm that starts from the center and finds two sums and then adds them up. So this should be easy to write. The maximum crossing subarray. Okay. Now, in an actual implementation of this, you will have to find a way to track the indices, because we are not only interested in returning the sum, we are interested in returning the indices that give us the maximum sum. So in this case, the indices are 1 and 4. 1 is the start index, and 4 is the end index. Okay? All right, so now, who can analyze this algorithm? So this is divide and conquer. So who can analyze this? So let's first write a recurrence. Well, is this like quick sort or merge sort?
Merge sort?
Yeah, why is it like merge sort?
Divided from center.
Yeah, so this is an easy one. We always divide in half. So the division is always the same. So it's going to be
Merge sort?
yeah, why is it like merge sort?
Divided from center.
Yeah, so this is an easy one. We always divide in half. So the division is always the same. So it's going to be easy, like merge sort. It's not going to be complicated like quick sort. So this is T of n. What's this? This is the base case. And what's this?
It's constant.
What is it? What does it mean? This is the divide time, yes. This is the divide time. Equals theta of 1. And what's this? The maximum subarray of on the left-hand side. So what's the running time for this? Yeah, it's T of n by 2. And this? T of n by 2. And this?
T of n.
T of n, because this is a single scan, right? If we start from the center and we go left, and each process takes constant time, we just compute the max. And again, a linear scan from center to right. So this is theta of n. And what's this? So this is the combined time. What's the combined time here? Finding the max of 3 numbers, it's constant. Finding the max of 3 numbers is a constant. So now the recurrence relation is going to be T of n equals 2T of n over 2 plus theta of n, which is same as merge sort. And whatever, it's the same as merge sort because you have T of n over 2, T of n over 2, and whatever processing you are doing at the processing that you are doing at each level is linear time, which is in this case finding the maximum crossing subarray.
था ना, वहाँ पर भी ये मैनिपुलेट होके यहाँ पर 6 आ गया होगा, यहाँ पर 5 आ गया होगा, यहाँ 4 आ गया होगा, वो आ गया होगा क्योंकि हम सेम अरे को ही मैनिपुलेट कर IDX ही करेंगे। जो जो यहाँ बताया ना, सेम वेरिएबल भी सेम यूज करेंगे इन डिसेंडिंग ऑर्डर। ठीक है, केथ लार्जेस्ट एलिमेंट। ओके, अब देखो अप्रोच 1 मैंने बता दिया था यूजिंग सॉर्टिंग अपने ही प्लेलिस्ट के 12th वीडियो पे। अप्रोच 2 भी उसी वीडियो में बता दिया था। आज अप्रोच 3 बताना है यूजिंग क्विक सेलेक्ट। अच्छे से क्विक सेलेक्ट को समझेंगे, ठीक है, और इंट्यूटिवली समझेंगे। मैं आपको एल्गोरिदम रटवाऊंगा नहीं कि होयर्स एल्गोरिदम ने क्या बोला था, और एज इट इज कोड नहीं लिखूंगा, ठीक है। आपको लॉजिक भी समझ में आना चाहिए ना कि क्यों लिखा है, वरना फिर भूल जाओगे, ठीक है। समझना ज़्यादा ज़रूरी है, ठीक है। तो पेशेंटली इसको समझो, ओके। देखो इसको स्टार्ट करने से पहले ना एक बड़ा बेसिक सा चीज़ आपसे पूछता हूँ। मैं कि मान के चलते हैं यहाँ पर एक एलिमेंट है ए, ठीक है, और मैं आपको ये बोलता हूँ कि ए के लेफ्ट साइड में जितने भी एलिमेंट है ना सब उससे बड़े हैं, मतलब सारे जो हैं वो ग्रेटर देन ए हैं। जितने भी एलिमेंट है, मान लेते हैं यहाँ पर बी है, सी है, डी है, ठीक है, लेफ्ट साइड में जितने एलिमेंट है, और ए के राइट साइड में जितने एलिमेंट है वो सब ए से छोटे हैं, ठीक है। मतलब ए बड़ा है उन लोगों से। मान लेते हैं ई है, एफ है, ठीक है। अब देखो मैं आपको ये नहीं बोल रहा कि बी सी डी को अलग से सॉर्ट करो, मैं आपको ये भी नहीं बोल रहा कि आप ई और एफ को सॉर्ट करो। ना इंश्योर कर लो कि ए के लेफ्ट साइड में जितने एलिमेंट है ना वो ए से बड़े होने चाहिए, और ए के राइट साइड में जितने एलिमेंट है वो ए से छोटे होने चाहिए, ठीक है। इससे देखो फायदा क्या होगा। देखो तो ए के लेफ्ट साइड में कितने एलिमेंट है, 3 एलिमेंट है, तो और ए के राइट साइड में 2 एलिमेंट है, ठीक है। ए के लेफ्ट साइड पर ध्यान दो, यहाँ 3 एलिमेंट है ना, तो आप देखो इन लोगों को सॉर्ट करोगे भी ना। मान लेते सॉर्ट कर दिया बी सी डी, तो कैसे भी इसको सॉर्ट कर लो, रीअरेंज कर लो, सारे एलिमेंट्स ए से तो बड़े ही है ना। तो डिसेंडिंग ऑर्डर में रखने के लिए ये तीनों तो एनीवेज लेफ्ट साइड में ही रहेंगे ए के, है ना, क्योंकि ये सारे एलिमेंट ए से बड़े हैं और मुझे डिसेंडिंग ऑर्डर में मान लेते हैं चाहिए। तो सारे के सारे को कैसा भी अरेंज कर लो वो ओ के लेफ्ट साइड में ही रहेंगे ना, ए के लेफ्ट साइड में ही रहेंगे ना, क्योंकि वो ए से बड़े हैं और मुझे डिसेंडिंग ऑर्डर में रखना है, ठीक है। तो ए के लेफ्ट साइड में कितने एलिमेंट है, 3 एलिमेंट है। तो मैं 110% होके ये बोल सकता हूँ ना कि ये चौथा बंदा है, ये फोर्थ एलिमेंट होगा, ये फोर्थ एलिमेंट होगा अगर इसको सॉर्ट कर दिया जाए पूरे के पूरे अरे को। अगर इस पूरे के पूरे अरे को सॉर्ट कर दिया जाए तो ये जो ए है ना ये मेरा फोर्थ बंदा होगा, या तो मैं ऐसे बोल सकता हूँ कि जो मेरा ए है ना वो फोर्थ लार्जेस्ट एलिमेंट होगा, पक्का। ऐसा क्यों? क्योंकि देखो ए के लेफ्ट साइड में सारे एलिमेंट ए से बड़े थे, बी सी डी, ठीक है। तो इन बी सी डी में हो सकता है कोई फर्स्ट लार्जेस्ट हो, सेकंड लार्जेस्ट हो, थर्ड लार्जेस्ट हो, उसके बाद ए आया, तो 110% श्योर हो ना कि ए फोर्थ लार्जेस्ट एलिमेंट है। और ई और एफ का टेंशन मत लो, क्योंकि ई और एफ तो छोटा है ए से। मैंने बोला था ना कि ए के राइट साइड में जितने एलिमेंट है वो ए से छोटे हैं। मुझे फोर्थ लार्जेस्ट चाहिए, मैंने इंश्योर कर लिया कि ए के लेफ्ट साइड में जो 3 एलिमेंट है वो सारे ए से बड़े हैं, तो पक्का ये चौथा एलिमेंट है ए जो कि बड़ा है, ठीक है। तो ये चीज़ आपको समझ में आ गया ना। देखो सेम यही कोर कंसेप्ट यही है, ठीक है। और जब पार्टीशन एल्गोरिथम पढ़ाऊंगा ना तो ये चीज़ फिर दोबारा आएगा। ठीक है, अभी अब यहाँ ध्यान दो, आपने क्या किया था, आपने ऐसा कुछ किया जिससे ए यहाँ पर आया और ए के लेफ्ट साइड में सारे ए से बड़े हो गए और राइट साइड में सारे ए से छोटे हो गए, तो ए फोर्थ लार्जेस्ट हुआ। बट किसी ने बोला भाई नहीं, मुझे फोर्थ लार्जेस्ट नहीं चाहिए, मुझे थर्ड लार्जेस्ट वाला बंदा चाहिए, मुझे थर्ड लार्जेस्ट वाला बंदा चाहिए। तो मैं बोलूंगा ना कि अच्छा थर्ड लार्जेस्ट चाहिए, बट मैंने तो फोर्थ निकाल दिया है, तो मुझे लेफ्ट साइड में ही कहीं देखना पड़ेगा। तो लेफ्ट साइड में देखो तो कौन कौन है, बी सी और डी है ना। लेफ्ट साइड में बी है, सी है और डी है, याद करो। लेफ्ट साइड में बी सी और डी है ना, तो याद करो ए जब फोर्थ लार्जेस्ट था, किसी ने मुझसे पूछा भाई थर्ड लार्जेस्ट चाहिए, ठीक है, तो ऑब्वियस सी बात है मैं कहाँ जाऊंगा, लेफ्ट साइड जाऊंगा। देख रहे हो, लेफ्ट साइड बी सी डी के पास जाऊंगा। ठीक है, तो मुझे बी सी डी मिल गया यहाँ पर। अब मुझे यहाँ पर निकालना है थर्ड लार्जेस्ट, है ना। तो इसमें याद करो, इसमें क्या होगा, लेफ्ट साइड बी सी डी के पास जाऊंगा। ठीक है, तो ऑब्वियस सी बात है मैं कहाँ जाऊंगा, लेफ्ट साइड जाऊंगा। देख रहे हो, लेफ्ट साइड बी सी डी के पास जाऊंगा। ठीक है, तो मुझे बी सी डी मिल गया यहाँ पर। अब मुझे यहाँ पर निकालना है थर्ड लार्जेस्ट, है ना। तो इसमें याद करो, इसमें क्या होगा, मान लेते हैं थर्ड लार्जेस्ट मेरा डी है, तो मैं कुछ ऐसा करूंगा कि डी यहाँ पर आ जाए। ठीक है, और डी के लेफ्ट साइड में सारे उससे बड़े एलिमेंट होंगे, बी और सी, और डी के राइट साइड में सारे उससे छोटे एलिमेंट होंगे। सिंस यहाँ पर कोई भी छोटा एलिमेंट नहीं है तो यहाँ पर नहीं डालेंगे। ठीक है, तो अब देखो, सिंस हमारा लेफ्ट साइड में दो एलिमेंट है और दोनों डी से बड़े हैं, ठीक है, तो पक्का ये तीसरा एलिमेंट होगा, ये थर्ड एलिमेंट होगा। ठीक है, और सिंस ये डिसेंडिंग ऑर्डर में, देखो ये सारे बड़े थे डी से, उसके बाद जस्ट बड़ा ये है, उसके बाद तो छोटे हैं राइट साइड में। ठीक है, तो ये पक्का थर्ड लार्जेस्ट होगा। ठीक है, कंसेप्ट यही है। अब सही यही सेम कोर कंसेप्ट ना अभी अपने पार्टीशन एल्गोरिथम में लगाएंगे, आपको डेफिनेटली क्लियर हो जाएगा। ठीक है, और पार्टीशन एल्गोरिथम लगाने से पहले मैं एक और चीज आपको बोल दूं कि याद करो, इस बार मैंने फोर्थ लार्जेस्ट निकाल लिया था, लेकिन किसी ने मुझे बोला कि भाई थर्ड लार्जेस्ट चाहिए, तो मैं लेफ्ट साइड चला गया था। अगर मान लेते वो बंदा बोलता भाई फिफ्थ लार्जेस्ट चाहिए, तो मैं राइट साइड चला जाता, राइट है ना, राइट साइड चला जाता। तो यही सेम कंसेप्ट अभी हम लगाएंगे अपने पार्टीशन एल्गोरिथम में। ओके, तो चलो स्टार्ट करते हैं अपना रिवर्स पार्टीशन। ठीक है, क्विक सिलेक्ट एल्गोरिथम समझने की कोशिश करते हैं। देखो अभी स्टार्टिंग में तो पूरा का पूरा अरे पे सर्च मार रहे हैं ना, तो यहाँ पर एल लिख देते हैं, यहाँ पर इसको एल मान लेते हैं और इसको आर मान लेते हैं। याद करो ना, जब मैं समझाया था अभी थोड़ी देर पहले, तो मैं बोल रहा था ना कि पहले पूरा अरे पे सर्च मारा हमने, फिर उसको डिवाइड किया यहाँ पर ऐसे, इधर हाफ में लेफ्ट और राइट में। ठीक है, और किसी ने पूछा था, ये याद है फोर्थ लार्जेस्ट मिल गया था, तो किसी ने बोला थर्ड लार्जेस्ट चाहिए, तो नेक्स्ट मैं इस पे सर्च मार रहा था, एल यहाँ आ जाता, आर यहाँ आ जाता। ठीक है, तो अभी स्टार्टिंग में तो पूरा का पूरा अरे है ना, तो एल यहाँ पर है और आर यहाँ पर है। ठीक है, बढ़िया। अब याद करो मैंने बोला था ना कि किसी एक एलिमेंट को लेंगे और ऐसा करेंगे कि वो एलिमेंट बीच में हो और उसके लेफ्ट साइड में सारे बड़े एलिमेंट हो ए से, और राइट साइड में सारे छोटे एलिमेंट हो। अब वो एलिमेंट आप किसी को भी चुन सकते हो। ठीक है, वो एलिमेंट आप किसी को भी चुन सकते हो सकता है वही आपका केस लार्जेस्ट एलिमेंट हो जाए, हो सकता है, तो किसी को भी चुन लो, तो उसी को पिवट बोलते हैं, है ना, उसी को पिवट बोलते हैं, जिसको आप चुनते हो ना बीच में, और लेफ्ट साइड में बड़े एलिमेंट, राइट साइड में छोटे एलिमेंट, उसको पिवट बोलते हैं इसको। तो अब देखो पिवट चुनने का भी बहुत सारा तरीका होता है। एक कुछ लोग बोलते हैं रैंडम कोई इंडेक्स उठा लो, उसको पिवट चुन लो। ठीक है, मैं क्या करूंगा, अब देखो अब आप पर है, आप किसी को भी पिवट चुन सकते हो। मैं पिवट चुनता हूँ इसको। ठीक है, मैं पिवट इसको चुन लेता हूँ जो लेफ्ट मोस्ट पर है। ठीक है, किसी को भी चुन सकते हो। अब उसके बाद आगे बढ़ते हैं। आगे बढ़ने से पहले याद करो मैंने आपको बोला था ना कि जो पिवट बंदा है कुछ ऐसा होना चाहिए कि पिवट बीच में हो, लेफ्ट साइड सारे बड़े एलिमेंट, राइट साइड सारे छोटे एलिमेंट। ठीक है, तो एक एग्जांपल लो, यहाँ पर मान लेते हैं यहाँ पर बी है, ठीक है, जो कि पिवट एलिमेंट है। ठीक है, यहाँ पर मान लेते हैं एक्स है और यहाँ पर वाई है। ठीक है, तो इसका मतलब क्या हुआ, एक्स जो है बी से बड़ा होना चाहिए, है ना, एक्स शुड बी ग्रेटर देन बी एंड वाई शुड बी लेस देन बी, यही होना चाहिए ना। बट अगर मान लो एक्स से लेस देन बी हुआ तो, और वाई अगर ग्रेटर देन बी हो गया, तो इसका मतलब क्या हुआ, देखो वाई ग्रेटर देन बी है ना, तो वाई को लेफ्ट साइड होना पड़ेगा। क्यों, क्योंकि पिवट के लेफ्ट साइड में सारे बड़े एलिमेंट होंगे। तो देखो इफ एक्स इज लेस देन बी एंड वाई इज ग्रेटर देन बी, तो हमें क्या करेंगे, वाई को यहाँ ले आएंगे, एक्स को यहाँ ले आएंगे। एक्स को क्यों यहाँ राइट साइड ले आए, क्योंकि बी से छोटा है वो, ये रहा। ठीक है, ये चीज क्लियर हो गया। तो सेम चीज मैं यहाँ पर लगाऊंगा, इसको मैं इरेज कर देता हूँ, सेम चीज मैं इधर भी लगाने वाला हूँ। ठीक है, ड्राई रन से देखना पूरा आप समझ जाओगे पूरा का पूरा। ठीक है, अब देखते हैं लेफ्ट साइड में ये ith एलिमेंट है, ये यहाँ पर जे है। ठीक है, और पिवट तो अभी मेरा 3 है, यहाँ तक क्लियर है। तो याद करो मैंने बोला ना ये एक्स है और ये वाई है, और ये मेरा पिवट भी इसी को मैंने मान लिया। ठीक है, तो मैंने लिखा था ना कि जो नम्स ऑफ आई है, ठीक है, नम्स ऑफ आई है, अगर वो लेस देन पिवट है ना, नम्स ऑफ जो भी पिवट इंडेक्स है मेरा, नम्स ऑफ पी, या तो डायरेक्ट पी में स्टोर कर लेंगे पिवट इंडेक्स, पिवट एलिमेंट, अगर पी से वो छोटा है, एंड जो नम्स ऑफ जे है वो अगर ग्रेटर देन पी है, इसका मतलब क्या हुआ, हमें पोजीशन चेंज करना पड़ेगा इनका, राइट। देखो नम्स ऑफ आई लेस देन पी है ना, तो जो लेस देन है उसको राइट साइड जाना पड़ेगा। ठीक है, बट ये तो है लेफ्ट साइड में, तो उसको राइट साइड भेजना पड़ेगा। तो उस केस में क्या करते हैं, स्वैप कर देते हैं नम्स ऑफ आई को और नम्स ऑफ जे को। ये कंडीशन तो समझ में आ गया होगा आपको, है ना। बट यहाँ पर देखते हैं यहाँ पर ऐसा हुआ है क्या, देख लेते हैं। नम्स ऑफ आई में कौन है, 3 है, नम्स ऑफ जे में कौन है, अच्छा पिवट एलिमेंट क्या है, 3 है, और नम्स ऑफ जे में कौन है, 4 है, पिवट एलिमेंट क्या है, 3 है। ठीक है, तो ये तो कंडीशन पास नहीं हो रहा है ना, ये कंडीशन तो पास नहीं हो रहा, 3 लेस देन 3 थोड़ी होता है। तो इसका मतलब क्या हुआ, ये तो गड़बड़ हो गया। ठीक है, बट देख लेते हैं ना, अब सिंस ये दोनों स्वैप होने लायक तो नहीं रहा, ठीक है, ये कंडीशन तो नहीं हुआ, तो या तो अब क्या हो सकता है कि नम्स ऑफ, तो या तो अब क्या हो सकता है, नम्स ऑफ जे में कौन है 4 है, पिवट एलिमेंट क्या है 3 है, इतना 3 थोड़ी होता है। तो इसका मतलब क्या हुआ, ये तो गड़बड़ हो गया, ठीक है। बट देख लेते हैं ना, अब सिंस ये दोनों स्वैप होने लायक तो नहीं रहा, ठीक है, ये कंडीशन तो नहीं हुआ, तो या तो अब क्या हो सकता है कि नम्स ऑफ आई, ठीक है, वो ग्रेटर देन पी हो ऑलरेडी, या तो ग्रेटर देन या तो इक्वल टू पी भी हो सकता है, डुप्लीकेट भी हो सकते हैं, ठीक है। और देखो ये एकदम सही चीज़ भी है ना, ये तो ऑलरेडी वही चीज़ है जो मैं चाहता हूँ। देखो नम्स ऑफ आई ग्रेटर देन इक्वल टू पी ये है और आई आता है लेफ्ट साइड है, तो लेफ्ट साइड में सारे पी से बड़े एलिमेंट होने चाहिए, और देखो ऑलरेडी बड़ा है भी, तो अगर ये केस है तो ये हैप्पी केस है ना। तो मैं कुछ नहीं करूँगा, आई को आगे आगे बढ़ा दूंगा, बस हमें जो चाहिए था वो तो मिल गया, आई प्लस प्लस कर दूंगा, ठीक है। या फिर नम्स ऑफ जे जो है, जे मतलब पी के जो राइट साइड में एलिमेंट्स है उसको पी से छोटा होना है, तो ऑलरेडी वो होगा, तब स्वैप कर, अब दोनों गड़बड़ हो, है ना, ये लेफ्ट साइड वाले एलिमेंट पिवट से छोटे हो गए और राइट साइड वाले एलिमेंट पिवट से बड़े हो गए, तब स्वैप करना पड़ेगा, राइट। तो देख लेते हैं यहाँ पे हमारे पास कौन सा केस है। यहाँ पर हमारे पास पहला केस तो यहाँ पर आ गया, ठीक है, इधर ही फॉर लूप से निकले से बड़े हैं, ये रहा, ये देखो 5 4 6, पिवट के राइट साइड में सारे एलिमेंट पिवट से छोटे हैं, ठीक है। अब आएगा मजा, अब देखो पिवट ये डिसेंडिंग ऑर्डर लग तो रहा है, बट ये खुद में सॉर्टेड नहीं है, बट मुझे फर्क नहीं पड़ता ना, मुझे इतना तो पता है कि पिवट के लेफ्ट साइड में सारे एलिमेंट पिवट से बड़े हैं, तो ये पहला लार्जेस्ट ये है, दूसरा लार्जेस्ट ये है, तीसरा लार्जेस्ट ये है, ये चौथा लार्जेस्ट है, फोर्थ लार्जेस्ट है, ठीक है। तो मैं गया फिर पूछा कि भाई कितना लार्जेस्ट चाहिए तुम्हें, तो मैंने बोला कि भाई मुझे सेकंड लार्जेस्ट चाहिए, ठीक है। बट मैं किसको ले आया, फोर्थ लार्जेस्ट को ले आया, तो सेकंड लार्जेस्ट कहाँ पर होगा, लेफ्ट साइड में कहीं पर होगा, तीनों में से कोई एक होगा ना, फर्स्ट लार्जेस्ट ये है, सेकंड लार्जेस्ट ये, थर्ड लार्जेस्ट ये है, सेकंड लार्जेस्ट ये, थर्ड लार्जेस्ट ये, तो लेफ्ट साइड जाना पड़ेगा ना, क्योंकि मैंने निकाल के ले आया फोर्थ लार्जेस्ट, ठीक है। इसका इंडेक्स देखो 0 1 2, इसका इंडेक्स 3 है, मुझे चाहिए सेकंड लार्जेस्ट, ठीक है, जिसका इंडेक्स कहाँ पर होना चाहिए, 1 पे होना चाहिए ना। अगर ये डिसेंडिंग ऑर्डर में सॉर्ट हो जाता तो सेकंड लार्जेस्ट कौन से इंडेक्स पे होता, 1th इंडेक्स पे होता, तो ऑब्वियस सी बात है मुझे लेफ्ट साइड जाना पड़ेगा, तो लेफ्ट साइड में सेम चीज अप्लाई करूंगा क्या, इस बार इस देखो अब लेफ्ट साइड मुझे जाना पड़ेगा, तो मैं क्या करूंगा, सिर्फ इस अरे पे छानबीन करूंगा, इस बार एल मेरा ये है और आर मेरा ये है, ठीक है। देख लेते हैं 5 4 6 है ना, तो सेम चीज में जो सेम कांड मैंने ऊपर किया, मैं अब सेम कांड यहाँ के लिए करूंगा 5 4 6 के लिए, ठीक है। एल यहाँ पर है, आर यहाँ पर है, फिर वही कांड करूंगा कि मैं इसको पिवट मानूंगा, और ये आई और ये जे है मेरा, ठीक है। अब फिर से वही कंडीशन चेक करते हैं, देखते हैं नम्स आई क्या है भाई, नम्स आई 5 है, और उसके बाद कंडीशन क्या था, लेस देन पिवट होना चाहिए, तो लेस देन पिवट, पिवट तो मेरा 5 है भाई, ये तो नहीं, जे वही का अगर ग्रेटर देन पिवट हो गया मतलब करते तो जे यहाँ आ गया, क्या बोलता था 5, यहाँ पर 6 आ जाएगा और यहाँ पर 5 आ जाएगा, तो पिवट मेरा यहाँ आ गया ना एक्चुअली में, ठीक है, पिवट मेरा यहाँ आ गया, जे इंडेक्स पे मेरा पिवट आ गया, ठीक है। अब देखो ध्यान दो, लेफ्ट साइड में देखो, ध्यान दो, लेफ्ट साइड में कितने एलिमेंट है, एक एलिमेंट है जो कि 5 से बड़ा है, राइट साइड में एक एलिमेंट जो कि राइट साइड में सारे छोटे एलिमेंट, लेकिन ध्यान दो लेफ्ट साइड में कितना बड़ा एलिमेंट है, सिर्फ एक ही बड़ा एलिमेंट है, तो पक्का ये दूसरा बड़ा एलिमेंट होगा, यानी कि ये सेकंड लार्जेस्ट एलिमेंट होगा, सेकंड लार्जेस्ट। और ध्यान दो इसका इंडेक्स क्या है, ये 0th इंडेक्स है, ये फर्स्ट इंडेक्स है, तो इस बार मैं फर्स्ट लेकर जाऊंगा, फिर से पूछूंगा भाई कितना लार्जेस्ट चाहिए था, मैं बोलूंगा भाई मुझे दूसरा सेकंड लार्जेस्ट एलिमेंट चाहिए, यानी कि फर्स्ट इंडेक्स में जो भी एलिमेंट होगा आफ्टर सॉर्टिंग इन डिसेंडिंग ऑर्डर, है ना, इंडेक्स कौन सा चाहिए, 1 वाला चाहिए, और इस बार देखो मुझे 1 वाला ही मिला है पिवट, ठीक है। यानी कि इस बार क्या हुआ, जो मुझे चाहिए एक्जैक्टली वही इंडेक्स मिल गया है, तो मैं बोल दूंगा कि ये जो तुम्हें इंडेक्स मिला ना, इंडेक्स नंबर 1 वही है मेरा सेकंड लार्जेस्ट, ठीक है, और मुझे सेकंड लार्जेस्ट ही चाहिए था और वो मुझे मिल गया है, आंसर क्या है 5। और मैं आपको बता दूं कि ये जो मैं स्वैप करके चेंज कर रहा हूं, देखो 6 यहाँ आ गया, 5 यहाँ आ गया, 4 यहाँ आ गया, वो सेम अरे में कर रहा हूं मैं, अलग से कोई अरे क्रिएट नहीं कर रहा, सेम अरे में ये मैनिपुलेशन चल रहा है, ठीक है। इसीलिए इसको बोलते हैं इन प्लेस एल्गोरिथम। पता है इन प्लेस एल्गोरिथम क्यों बोलते हैं, क्योंकि जो इनपुट अरे दे रखा है ना, आप उसी में मॉडिफिकेशन करते जा रहे हो, अलग से आप अलग से कोई अरे बना के उसमें मॉडिफाई नहीं कर रहे हो, जो इनपुट अरे है उसी पे आप मॉडिफिकेशन करते चलते जा रहे हो, है ना। जैसे देख लो यहाँ पर फर्स्ट इंडेक्स में 5 आ गया ना, ये तो ये जो ओरिजिनल अरे था ना, वहां पर भी ये मैनिपुलेट होकर यहाँ पर 6 आ गया होगा, यहाँ पर 5 आ गया होगा, यहाँ 4 आ गया होगा, वो आ गया होगा क्योंकि हम सेम अरे को ही मैनिपुलेट कर रहे हैं। तो देखो फर्स्ट इंडेक्स पे ये आ गया, ठीक है, और यही मेरा सेकंड लार्जेस्ट एलिमेंट, ठीक है। तो अभी देखो हमने पूरा ड्राई रन किया, ऐसा नहीं कि मैंने आधा करके छोड़ दिया, तो हमने इस हाफ पर आया तो इसका भी देखो मैंने लेफ्ट ड्राई रन किया, और ड्राई रन करके ही मैंने सीखा था इस एल्गोरिथम को, ठीक है। और ये काफी इंपॉर्टेंट है, जल्दी से इसका कोड करते हैं। देखो जो स्टोरी सुनाई ना, बिल्कुल सेम स्टोरी की तरह ही कोड करेंगे, एल लेंगे, आर लेंगे, ठीक है, फिर पार्टीशन करने के लिए एक पिवट लेंगे और एक जे
1, 2, 3, 4, 5, 6. The topic is minimum cost spanning tree. So for that, first of all, we'll understand what does it mean by a spanning tree. Here I have an example graph. Graph is represented as G and VE. V is the set of vertices 1, 2, 3, 4, 5, 6, and E is the set of edges. The set of edges are from 1 to 2 and 2 to 3, 3 to 4, and so on. Graphs are represented as set of vertices and edges. Now what is this spanning tree? Spanning tree is a subgraph of a graph. Since I should take the subset of this. So subset of what? What vertices and edges, both the subset or only one subset? So I should take the subset of edges. Vertices must be as it is. So I should take all vertices, 6. Spanning tree means I should take all vertices. Then how many edges? How many vertices I have? Number of vertices are n, that is 6. So I should take number of vertices minus 1, that is only 5 edges. Spanning tree is a subgraph of a graph having all vertices but only n minus 1 edges. So out of these edges, I should take only 5. So 1, 2, 3, 4, 5. I did not take this one. So this is spanning tree. See, a tree will not have a cycle, so there is no cycle here. Yes, there is no cycle here. If this you can say it's a cycle. If you start from one vertex, you can again reach back to that vertex. But here, there is no cycle. Is it possible that I will take this one, but I will not take this? Yes, there's also a spanning tree. I will take this, but I will not take this. Yes, this is also a spanning tree. So which edge to select, that is a choice. That is a choice for a spanning tree. So I can say that S is a subgraph of a graph where S is defined as set of vertices and set of edges, where set of vertices are same as the vertices of a graph and edges are number of vertices minus 1. So the number of edges are number of vertices minus 1. This is how formally we can divide. In mathematics we can define like this. Now next thing, for a given graph, how many different spanning trees can be generated? I want to know that how many different spanning trees are possible. So see, number of edges are how many? 6. 1, 2, 3, 4, 5, 6. In a spanning tree, I should take only 5. I should take only 5. So 6C5. Out of 6 edges, I have to select 5. How many ways I can do that? So 6, 5, C ways. So 6, 5, C is how much? 6 only. So I can have 6 different spanning trees. Just now you can see it's a simple one that I have skipped this edge. Like this I can leave one edge, right? And you can form a spanning tree, right? I can take all except this, take all except this, take all except this. 6 are possible. Suppose if I have one more edge now. Now I have 7 edges and I want to select 5. Now how many spanning trees are possible? next topic is, see, I have this spanning tree also. Or I can have this spanning tree also. The possibilities are more. Now this is 7C5. 7C5. But this edge will form cycle. So how many cycles it is forming? This is one cycle and this is another cycle. So this edge is forming two cycles of number of vertices less than 6. So if it is forming number of vertices less than 6, then you will be 7C5 minus 2. So that's it. So what's the formula to know how many different spanning trees are possible from a given graph? So whatever the number of edges you have, you should take all those and see of how many edges you need. You need 5. So 5 is what? Number of vertices minus 1. So this is number of vertices minus 1 and minus number of cycles. You have to subtract number of cycles. I have a graph where the edges are having weights. Cycles. I have a graph where the edges are having weights. So this is a weighted graph. This is a weighted graph. I want to know what are the possible spanning trees possible. So I'll draw a few spanning trees. Let us draw one spanning tree. This is vertex 1 and 2 and 3 and 4. So 4 vertices are there. Then how many edges I should take? 4 minus 1, only 3. So I'll select this one. 1, 2, 3. So what is the weight of this one? 5, 3 and 6. So what is the cost of this spanning tree? Cost of this spanning tree is 14. I'll take one more spanning tree. 1, 2, 3, 4. And I'll take these edges. Let us see what is the cost of this. 4, 6, 3. Then what is the cost of this one? 13. I'll take one more spanning tree. 1, 2, 3, 4. And I'll take these edges. This one and this one and this one. 4, 2 and 3. So this is, cost is how much? 9. Now, from this example, some observation, we can understand something. If you have a weighted graph and you get different spanning trees, the cost of the spanning trees may be varying. You can get a different cost of spanning trees. Now, the problem is, can I find out the minimum cost spanning tree? Can I find out the minimum one which gives me minimum? Yes, you can find out. How? You can try all possible spanning trees, and then from that you can check whichever is minimum, you can pick up that answer. This is one method. Trying all possible spanning trees will be too lengthy. Is there any greedy method? Yes, the greedy methods are available for finding the minimum cost spanning tree. If a weighted graph is given, you can find out the minimum cost spanning tree by following the method without finding out all possible spanning trees. So what are those methods? One method is Prim's algorithm, and the second method is Kruskal's algorithm. There are two algorithms for finding minimum cost spanning tree. I have a weighted graph here, and I have to find a minimum cost spanning tree by following Prim's algorithm. Let's see how Prim's algorithm works through an example. Now, as per Prim's algorithm, he says that from a graph, first of all, you select a minimum cost edge. So the smallest edge in the entire graph is this one. Then, this is the initial one. Now for the rest of the procedure, always select a minimum cost edge from the graph, but make sure that it should be out all possible spanning trees. So what are those methods? One method is Prim's algorithm, and the second method is Kruskal's algorithm. There are two algorithms for finding minimum cost spanning tree. I have a weighted graph here, and I have to find a minimum cost spanning tree by following Prim's algorithm. Let's see how Prim's algorithm works through an example. Now, as per Prim's algorithm, he says that from a graph, first of all, you select a minimum cost edge. So the smallest edge in the entire graph is this one. Then, this is the initial one. Now for the rest of the procedure, always select a minimum cost edge from the graph, but make sure that it should be connected to already selected vertices. Prim's algorithm. Let's see how Prim's algorithm works through an example. Now, as per Prim's algorithm, he says that from a graph, first of all, you select a minimum cost edge. So the smallest edge in the entire graph is this one. Then, this is the initial one. Now for the rest of the procedure, always select a minimum cost edge from the graph, but make sure that it should be connected to already selected for finding minimum cost spanning tree. I have a weighted graph here, and I have to find a minimum cost spanning tree by following Prim's algorithm. Let's see how Prim's algorithm works through an example. Now, as per Prim's algorithm, he says that from a graph, first of all, you select a minimum cost edge. So the smallest edge in the entire graph is this one. Then, this is the initial one. Now for the rest of the procedure, always select a minimum cost edge from the graph, but make sure that it should be connected to already selected vertices. Now the next minimum is which one? 3 to 4. Don't take that. It will not be connected to 1 or 6. So take only those which are connected to 1 or 6. Means what he is trying to do is always maintain a tree. Prims thinks that if some farther away edge is selected, then it will not be forming a tree finally. So that is the reason he suggested that always select a minimum edge which should be connected. So let us see what's the next one. So for this connected one are this one and this one. So out of this 25 and 28, 25 is minimum. So select this 25. Then this 28 and 5 connected to 5 are 22 and 24. So out of this 28, 24 and 22. So from 1 and 6 and 5 I am checking. So already 6 is over. So 1 and 5. So out of those, this is the smallest one. So 4 is selected. Now from 1, 6 and 5, 4, who is smallest? The connected one. So this is 24 and 18 and 12. So 12 is a smaller. So we will take 12. Then out of all these, which connected is the smallest? So here I have 24, 18 and 16. So 16 is a smaller. So take that 16. Then out of all these, who is next connected? So from 2 to 7, there is an edge which is connected. So this is 7. That's it. There are 7 vertices. So 1, 2, 3, 4, 5, 6. 6 edges are selected, and this is how we got a minimum cost spanning tree. And this is how we got a minimum cost spanning tree. What is the cost of a tree? The cost of a tree is, if I add all these, it is 99. So the approach of Prim's is initially select the smallest one, then always select the connected smallest one. Alright? So this is the method of Prim's algorithm. Next, if I have a graph 1, 2, 3, 4, 5, 6, 7. If I have a graph like this which is not connected, there are total 7 vertices, but there are 2 pieces in the graph. Can Prim find out the minimum cost spanning tree for this one? No algorithm can find out, because we cannot find a tree for this one, spanning tree for this one. In a spanning tree, it must be connected. So for non-connected graph, we cannot find spanning trees at all. But if I start Prims on this one, starting from vertex 1, if it is starting, then it may find the spanning tree for only one component, not the other component. Next method for finding minimum cost spanning tree is Kruskal's method. This also follows a greedy approach. Instead of trying out all possible spanning trees, it shows a procedure by following which we can get a minimum cost spanning tree. It says that always select a minimum cost edge. Always select a minimum cost edge. Let us follow this one. Let's select smallest edge 1 to 6, that is 10. This one is the smallest, and the next smallest test is 3 to 4. So the second edge I'm selecting is 3 to 4, and its cost is 12. Next minimum is 2 to 7. Select 2 to 7, and this is 14. The next minimum is 2 to 3, that is 16. And after this, the next minimum edge is 7 to 4, but that is 18. If I select that, it will form a cycle. Yes, Kruskal method says that always select a minimum cost edge, but if it is forming a cycle, don't include it in the solution. Discard that edge, don't include an edge. So it means always select such that it is not forming a cycle. So if I include 4 to 7, it will form a cycle. So next one you check. So the next one is 22. So this is from 5 to 4 or 4 to 5. So this is 22. Next minimum is 24. So that is 7 and 5. If I include this also, it will form a cycle. Don't include that one. Then the next minimum one is 25. That is from 5 to 6. So this is 25. And the cost of this one is Hi, a knapsack problem. There's a well-known problem. First of all, we will know about the problem, then we will see how it can be solved, and then we'll also understand how greedy method is applicable here, and it is following greedy method. Let us understand this problem. See here, some objects are given. 1 to 7 objects are given. Every object is having some profit associated with it. And every object is having some weight. So objects are there, every object is having some profit, and every object is having weight. Okay, weight we understand. What is this profit? See, there is a bag given here. That bag is called as knapsack. The bag capacity is 15. These are 7 objects. Bag capacity is 15. There is a bag whose capacity is 15, let us say kg. Okay, it can be kgs also, pound also, it can be anything. So I am assuming it as kg. Now what we have to do is, we have to fill this bag with these objects. And hi, a knapsack problem. There's a well-known problem. First of all, we will know about the problem, then we will see how it can be solved, and then we'll also understand how greedy method is applicable here, and it is following greedy method. Let us understand this problem. See here, some objects are given. 1 to 7 objects are given. Every object is having some profit associated with it, and every object is having some weight. So objects are there, every object is having some profit, and every object is having weight. Okay, weight we understand. What is this profit? See, there is a bag given here. That bag is called as knapsack. The bag capacity is 15. These are 7 objects. Bag capacity is 15. There is a bag whose capacity is 15. Let us say kg. Okay, it can be kgs also, pound also, it can be anything. So I am assuming it as kg. Now what we have to do is, we have to fill this bag with these objects, and we will carry this bag to a different place, and we will sell away these objects. We get that profit. So that profit is the gain that you get by transferring these objects to some location. So for transferring, you have to carry them in this container or bag. So I can also call this knapsack as container. This is a bag or knapsack. I can also call it as container. So the problem is a container loading problem. So we find this type of problems in daily life. A lot of goods are transported daily from one place to another place. Now the problem is about filling of that container with the objects. When it becomes a problem, if you have the objects whose total weight is more than the capacity of the container or a bag, if you have less, all can fit in, then no problem at all. If you have the objects more in number, their weight is greater than the capacity of a bag, then it is a problem. So already we have some objects here. So I have to fill this bag with these objects such that the Profit is maximized. Profit is maximized. So this is a optimization problem, and it is a maximization problem. Maximization problem. Can we follow greedy method? Yes, we can follow greedy method on optimization problem if it is suitable. Next thing, what is the constraint here? The total objects included here in the bag, their total weight should be less than or equal to 15 kg. This is a constraint. So I can give various solution. I can say that just put only one object and take it. It's not maximum. I'll say all cannot fit in. It's not feasible. So it cannot be optimal. So there can be many solutions. You can say take this, that and all and fill this one. But we want maximum result. That's it. For a problem, there can be many solutions, but those solutions, the profit is maximized. Profit is maximized. So this is a optimization problem, and it is a maximization problem. Maximization problem. Can we follow greedy method? Yes, we can follow greedy method on optimization problem if it is suitable. Next thing, what is the constraint here? The total objects included here in the bag, their total weight should be less than or equal to 15 kg. This is a constraint. So I can give various solution. I can say that just put only one object and take it. It's not maximum. I'll say all cannot fit in. It's not feasible. So it cannot be optimal. So there can be many solutions. You can say take this, that and all and fill this one, but we want maximum result. That's it. For a problem, there can be many solutions, but those solutions which are giving, the solution which is giving maximum result is an optimal solution. Let us see how to solve this one. See, what I am going to do is, for these objects, I am going to include them. So I will write down whether the object is going to be included or not included, or how much it is included. I will write down here x values. So here I will be writing x1 or x2 or x3, right? X values I will be writing. So this x value can be either 0 to 1. This x can be from 0 to 1. So it means I can also take fractions. Yes. So now listen one thing very carefully. This knapsack problem is for those objects which are divisible. I have something of 5 kg means I need not take all 5 kg. I can just take 2 kg also, 1 kg also. So these objects can be divided. So what type of objects? If I take an example, these may be vegetables. 7 kg of potatoes, 5 kg of tomatoes, something. So instead of taking 5 kg, I can take 2 kg also. Means it can be divided. Yes. So this is not about those objects which are indivisible. Let us say 5 kg grinder, mixer, 7 kg washing machine. It cannot be divided. It cannot take half of that washing machine. So I have to take the full one. So here 15 kg. This is a so already we have some objects here. So I have to fill this bag with these objects such that the profit is maximized. Profit is maximized. So this is a optimization problem and it is a maximization problem. Maximization problem. Can we follow greedy method? Yes, we can follow greedy method on optimization problem if it is suitable. Next thing, what is the constraint here? The total objects included here in the bag, their total weight should be less than or equal to 15 kg. This is a constraint. So I can give various solutions. I can say that just put only one object and take it. It's not maximum. I'll say all cannot fit in. It's not feasible. So it cannot be optimal. So there can be many solutions. You can say take this, that and all and fill this one, but we want maximum result. That's it. For a problem, there can be many solutions, but those solutions which are giving, the solution which is giving maximum result is an optimal solution. Let us see how to solve this one. See, what I am going to do is, for these objects, I am going to include them. So I will write down whether the object is going to be included or not included, or how much it is included. I will write down here x values. So here I will be writing x1 or x2 or x3, right? X values I will be writing. So this x value can be either 0 to 1. This x can be from 0 to 1. So it means I can also take fractions. Yes. So now listen one thing very carefully. This knapsack problem is for those objects which are divisible. I have something of 5 kg means I need not take all 5 kg. I can just take 2 kg also, 1 kg also. So these objects can be divided. So what type of objects? If I take an example, these may be vegetables. 7 kg of potatoes, 5 kg of tomatoes, something. So instead of taking 5 kg, I can take 2 kg also. Means it can be divided. Yes. So this is not about those objects which are indivisible. Let us say 5 kg grinder, mixer, 7 kg washing machine. It cannot be divided. It cannot take half of that washing machine. So I have to take the full one. So here I can take the fraction of an object also. So that's how whatever I am including, that can be a fraction starting from 0 to 1. Now let us see how to include these objects in the back. What should be my criteria, method for including them in the back? You may be saying that this is giving highest profit, take that one first. Yes, that is giving highest profit, take that one first. But I can say that first fill the bag with smaller things so that I can get more and more things in the bag and I can make more profit. More things you carry, more will be the profit. So I prefer take these objects first with you may be saying that this is giving highest profit, take that one first. Yes, that is giving highest profit, take that one first. But I can say that first fill the bag with smaller things so that I can get more and more things in the bag and I can make more profit. More things you carry, more will be the profit. So I prefer take these objects first with 1 kg weight or smaller weights. So your idea is also good. Take the maximum profit one, and my idea is also good. Take the smaller weights one so that I can have more objects. But what is the right method? I should select the objects which is having highest profit by weight. Is 18 is the profit. So I say that 18 bucks is the profit. Then that profit is for 4 kg. It's not for 1 kg, it's for 4 kg. So per kg how much? So that's it. We should select the objects who are having highest profit by weight. Per kg, whoever is highest, that I should take. So I should calculate this one. So I will calculate profit by weight for all these objects. So this is 5 and this is 1.3 and this will be 3. This is 1 and this is 6 and 18 by 4 is 4.5 and this is 3. Now I have these profits and weights of all those objects. Yes, this is the right selection procedure for the object. So the object should be selected based on their profit by weight. So the one who is having highest profit by weight, that I should put it in the back first. All right. Now this is the greedy method. Let us see what the greedy method is doing. I was explaining you the problem so far. Then I said on what basis I should select this. Now we decided that we will select the object based on their profit by weight. This is our procedure. Now greedy method says that first you decide how you are going to select the input, then go on selecting the input one by one. So we already selected the method. We are going to select them by profit by weight. Now we will be going on including them one by one. So which object I should include first in the bag? The highest profit by weight, that is fifth object. So I will include this whole thing. So now this is 15 kg, right? So 15 minus how many kg this object is 1. So now remaining 14 kgs I have. So I have included that fifth object in the bag and I got the full profit 6. Now who is next? This one. I will select this one also, this whole, all 2 kgs I will take. So this is 14 minus 2 kgs. Now I have 12 kgs remaining in the bag. Now which is the next objects? So this is the highest, then this is the next highest, this is the third highest. I will select this object also completely full. So full means all 4 kgs I will include. This is weight, 4 kgs I will include. So this is 12 minus 4 is 8 kg. 8 kg I have included, right? So 8 kgs are remaining. Now which is the next one? So I have 3, these are 2. I can pick up any one. So I will select this object. So this is how many kgs now? This is 5 kgs. Don't look at the weight. Don't look at the weight. I am selecting this one. This is giving profit by weight. So this is 5 kg and I'll be getting 15 profit. So the profit is same only. For both of them, it is same. So I'll select this. So how many kgs are gone? 5 kgs. So 8 minus 5, I am left with just 3 kgs in the bag. Now next is which one? This one. So I will take this whole thing. So how many kg? 1 kg. So 3 kgs are there minus 1. Now I am left with 2 kg. Now which is the next one giving the profit? So this one. So I will include this. But this is how many kg? 3 kg. How much I have there? I have only 2 kgs remaining. So can I include all these 3 kgs there? No, I will be including only 2 kg there. So this is 2 minus 2, 0 it will become. But from this one, I'm not taking the full object. I'm just taking 2 kg out of 3. So this is 2 by 3. 2 by 3. So I am taking the fraction of this object, you said. Already I told you that these objects are divisible, so I am taking 2 kgs out of that. And what about this? This is not included. So I have a solution for this problem, and this is the solution. This shows how I am going to include the objects, which objects I should include so that I get the maximum profit. Now I have to calculate the profit and find out how much it is. I have just written here the values from 0 to 1. Now I will see total how much profit I get, and I will also verify the weight that I am getting 15 kg only or not. Here I write these values. 1 with weight 1 into 2 plus 2 by 3 into this weight 3 plus 1 into 5 plus 0 into 7 plus 1 into 1 plus 1 into 4 kg plus 1 into 1 kg. If I take this, this is 2 plus this is 2 plus 5 plus 0 plus 1 plus 4 plus 1. So this is 9, 10, 14 plus 1, 15. So yes, the total weight is 15 only. See, these are the x values. This is either from 0 to 1. So that I am multiplying with weights. So what is this? Sum of the xi into weight I. And that is less than equal to 15. So I have found out the total weight. I was just subtracting. Now I'm just verifying it. Now let me know the profit. So for profit also what I'll do is 1 into 10. 1 into 10 plus 2 by 3 into 5. 2 by 3 into 5 plus 1 into 15 plus 0 into 7, I will avoid writing it. Then 1 into 6, 1 into 6 plus 1 into 18, 1 into 18 plus 1 into 3, 1 into 3. This is the profit. So this is nothing but summation of xi into pi. Every x value is multiplied with profit. So this is showing how much quantity I am taking, x. Now what is this total equal to? This is 10 plus 2 into 1.3 plus 15 plus 6 plus 18 plus 3. So this is 54.6. So that's it. Our total profit is 54.6 and the total weight is 15. Once again, I'll show you something here. See, these objects are given. Then what is the constraint given in the problem? The constraint is what? Sum of the weights of the objects included in the bag should be less than equal to capacity of the bag. Yes, we have done it. See, total weight should be less than equal to 15 and this is satisfied. This is the constraint given in the problem. So we have taken that solution which is satisfying the constraint. Yes, the solution is satisfying. So this is feasible. And objective is what? Objective is sum of the weights, profits of the objects that are included should be maximum. This is the objective of a problem. And we have achieved both. Now quickly I will explain you how we have followed the greedy method. Once again I am explaining you. See, the objects are given and the bag is given. We have to include these objects in the bag such that the profit is maximum, but the total weight should not exceed that one. So we have to select some objects such that we guarantee that we are getting maximum profit. So we have decided the criteria of selection. Have we tried this object? No. Without trying, how you can say that that is the best one? Because the method we followed is best one. The method we followed is best one, that we selected those objects whose profit by weight is higher and definitely whoever per kg value is greater, that will give you the maximum profit. So that's all about knapsack problem. There is one more problem called 0-1 knapsack problem. That is different from this one. How it is different? Here, fraction of an object is allowed, but there, indivisible objects, fractions are not allowed. So this is container loading with vegetables or fruit. knapsack problem. There is one more problem called zero knapsack problem. That is different from this one. How it is different? Here, fraction of an object is allowed, but there, indivisible objects, fractions are not allowed. So this is container loading with vegetables or fruits like this, which are divisible things. Anything that is divisible. And zero one knapsack problem will be container loading with indivisible thing. Either you include that whole thing or you don't include it at all. So you cannot take the part of it. So that's all. So I'll be making videos for all the topics that are there in greedy, and then I'll move on to dynamic programming and so on. So I'll be covering the entire syllabus, what all the topics are there. procedure. We compare A of I with this is a smaller. This is one way. The other way is so single array of 8 elements is Hi, the topic is quicksort. First of all, let us understand what is the idea behind quicksort, on what basis it works, what is the base idea about it. So let us take an example. So the idea is, if suppose there are group of students in a class and a teacher asks them to set up first of all are smaller than, well, is it getting position? Why? Quicksort, it will take low and high. If low is less than high, means at least there are two elements. If so, then it will call partition algorithm by passing low and on 2. Me, you come in front. So in their place. This one also, this object also 8 kg. So yes, this is the idea of quick sort. So let us see, I have taken some icons here, some picture here to show you. Now if the topic is quick sort. First of all, let us understand what is the idea behind quick sort, on what basis it works. What is the base idea about it? So let us take an example. So the idea is, if suppose there are group of students in a class and a teacher asks them to arrange themselves in the increasing order of their height. There are two options. A teacher can show their places, like you go there and stand at the back, you come here and stand in the middle or front, whatever it is. So the teacher can show places to the students. This is one option. Second option is teacher can ask the student to arrange themselves. So every student will find his place in the sorted order. So the faster method or quick method will be the one if the students are finding their place. So yes, this is the idea of quick sort. So let us see, I have taken some icons here, some picture here to show you. Now if I ask the students to arrange themselves in the increasing order of height, the shortest person in the class, he knows what is his place. He will quietly come and stand in the Hi, the topic is merge sort. So, for understanding merge sort, first of all, we should know what is merging. So, let us know about merge, that is merging. See, merging is a process of combining two sorted lists into a single sorted list. So, if I have two lists, let us say A is one list, B is one list with some set of elements like now there are two lists given and I have taken equal sizes. They can be of different size also, but they are sorted. Now let us see how we can combine them such that the result is also sorted. So I'll prepare a third list, that is C. These lists can be in array also, or they can be in linked list also. So irrespective of data structure, just we are looking at two lists. Now let us understand how to combine them. So for each list, I need some index pointer. Let us take I here and J here and K for this C list, which is in the beginning of empty list. Now procedure starts. The procedure for merging is like this. Compare A of I with B of J. If A of I is smaller, then copy that one here. And the element which is copied there, you move index, and this index also moves to next location. Now next, compare A of I with B of J. This is smaller than this one, so copy this element and move to next element here. And here also move to next free location. Continue. A of I with B of J, 8 is smaller, copy this one. Then move to next. And move K also to the next. In the same way, if I continue now, 9 is smaller, 9 is copied, then it will move to the next one. Then 12 and 15, 12 is smaller, 12 is copied. Then it will move to next one here, and 15 and 17, so 15 is smaller. Then it will come to this one, I will move here, and these two are compared, 17 is smaller, and finally K will be on the next free space, and I is still here, J has crossed the list. Now we can see that one of the list has finished. Now remaining elements are there in one of the list. Here in example, list A is having some remaining elements. So simply copy those remaining elements. So that's it. I got a third list, that is with the sorted elements. So we have combined two lists by comparing the elements from each list, and whichever is smaller we have copied them and we got a sorted list. This process is merging. The property of this process is that if two lists are already sorted, then the result is sorted. So the important thing is the result is sorted. Now let us look at the time taken by this process. If I say this list is having m number of elements and this list is having n number of elements, then what is done here? M elements and n elements are copied here. So this list is having m plus n element. So what we did, just we compare the elements and we have written the list here. So the amount of time taken for moving the data from here to there is theta of m plus n. Though the time complexities are written just using variable n. But for merging, we use theta of m plus n. So this resemble becomes a notation for merging. M plus n means, okay, merging is being done there. So this has become like a notation for merge. Now we have understood merging. I will write on the algorithm or a procedure for merging. What the procedure I have shown you, same thing I will write on the code there. Algorithm merge, which takes list A and B and their sizes m and n. Algorithm merge is taking two lists AB and let us say M and N. It depends, whatever you like, you can pass the parameters. It depends on you. Now, what we are doing here? We have taken I, that is at beginning place, and J also at beginning place, and K also at beginning place. Initially, if you remember, that means I is 1, J is also 1, and K is also 1. So I am starting the indices from 1 onwards, not like C, C++ where we start from 0 onwards. So for making it simple, I am starting from 1 onwards. Now, what is the procedure? We compare A of I with B of J. So if A of I is less than B of J, then in C of K, I should copy A of I. If this is smaller, copy this one and move I and K also. So K plus plus and I plus plus. If this is not smaller, this is smaller, else in C of K plus plus, copy B of J plus plus. This process will continue. That's what we have seen. Compare them and copy whichever is smaller. So this process will continue. How long? As long as I is less than or equal to M and J is less than or equal to N. The size of the list is M and the size of this list is N. This process will continue. And once this process completes, this loop completes, we know that any one of the list will have some remaining elements. Like in our example, 18 was remaining in the first list. So I should copy the remaining elements. So we don't know in which list the elements will be remaining. Maybe in A or maybe in B. See, if suppose here I have few more elements, 18, 19, 25. So there are 3 elements. So I is pointing here. From here onwards, I should copy all the elements. Means wherever I is pointing, I should copy all the elements. Or else, here I may be having some elements, 19, 25, 30. So J may be here. So wherever J is, I should copy rest of the elements. So here I write for wherever I may be, don't initialize it, let it be at the same place wherever it is, and I is less than equal to M, I plus plus, and in C of K plus plus, copy A of I. So I plus plus is already there, so just I am saying copy the remaining elements from list A to list C. Otherwise, if there are some remaining elements in second list, then copy the remaining elements from second list. This is the procedure for merging. Here, this procedure, this while loop, is for comparing and copying the elements. Then the first for loop is if there are any remaining elements in list A, copy them to list C. Second for loop is if there are any remaining elements in list B, copy them into list C. This is merging. Now let us see if there are more than 2 lists, then how merging is done. Let me take more than 2 lists. Now here I have multiple lists. Let us see how I can merge them. So I can compare first elements of all these lists and copy the one which is very smaller. So as 2 is smaller, so I can copy in the final list as 2. Then as this is taken, now I should go on to the next element of this list. Now the smaller one is 3, copy this 3. Now as I have already taken this one, then I should go to next element of this list. So I should compare 4, 5, 8, 4. And this 4 is smaller, 2 are there, so I can copy the first one. So now this is completed, so I should go to next element here. So I should compare 6, 5, 8 and 4, and whichever is minimum I should take that. So in this way I can compare all the elements, first one element from each list and take the minimum one. So at a time I am merging multiple lists together. How many lists? 4 lists I am merging together. So this method, if I take example 4, then this will be called as 4-way merging. It will be called as four-way merging. So as four list, so four-way merging. So as many lists you have, and if you're following this procedure, then it is called as m-way merging. It is m-way merging. If I am merging just two lists at a time, see here I was trying to merge all four lists together at a time. If I merge just two lists at a time, then it is called as two-way merging. And mostly we follow this method, two-way merging. So let us see, if I have these four lists, how I can merge them by following two-way merging. Now two-way merging, I can take two lists and get one list. So that will be 3, 4, 5, 6, 9 and 12. And I will take these two lists and get one list, that is 2, 4, 8, 10, 16 and 18. Now I have two lists and I can merge these two into a single list. So one merge, then second merge, then third merge. So four lists are there, so I have to take pair of two lists at a time, pair of lists at a time and merge them. So I have to perform merge 3 times. This is one way. The other way is, suppose I just take this one, A, B, C, D, 4 lists are there. I can merge these two and get one list, list 1. Then I can merge these two, then I can get second list. Then I can merge these two and I can get a third list. Or else if A, B, C, D are list given, they can merge these two and get first list, and merge these two and get second list. Then I can merge these two and get third list. So I have various options available here. I can first merge A with D or A with C also. More than one possible patterns of merging are there. So when you follow two-way merging and you have multiple lists, then you can merge them in various patterns. So we have learned that multiple lists can be merged in various patterns. Now let us look at two-way merge sort. There are two merge sort method. One is two-way merge sort, other one is just a merge sort. Mostly people get confused with the two-way merge sort and merge sort. Actually, there is a minor difference between them. Two-way merge sort is a iterative process, repeating procedure that is using loop, and merge sort is a recursive procedure, a recursive algorithm. Let us talk about two-way merge sort. Already I have explained you m-way merging or two-way merging. M-merging means you can merge more than two lists, that is m list at a time. But two-way merge is two lists are taken at a time and they are merged. So we'll follow that one for sorting the numbers. Here a list is given, array is given. Array is having 8 elements and I have to sort this array. But I have to sort this using merge process. So how I can merge? I need at least 2 arrays for merging and that must be sorted. But this single array is given and even that is not sorted. So what I can do is, I will assume that each element in the array is a list. So there are 8 lists containing one element in each list. Each list is having just a single element. So if there is a single element, then it means it is already sorted. So yes, can I merge them? Yes, I have to merge 8 lists into a single sorted list. So that's how I will merge all of them. Shall I merge all of them together? No, I will follow two-way merge method. So using two-way merge, I will merge them into a single list that will be a sorted list. So let us do. I'll select first 2 lists. Actually these are 2 elements, but I am calling them as 2 lists. Merge them. So what I get, 3 is smaller than 9. So I got one list, that is merging of those 2 is done. I got a single list with 2 elements. Then I'll merge these two, 5 and 7. Now I got one more list with 2 elements. Next I'll merge these two, so I get 4 and 6, and same way 2 and 8. 2 is smaller than 8. So I have merged these two and I got a sorted list of 2 elements. So I got such sorted list of 2 elements each. Now there were 8 lists, now I have 4 lists. And I have completed all the elements. So this is first pass. One pass is completed. I have gone through all n elements. Now one more thing. If there were 9 elements, then ninth element will not have pairing with anybody, so that will come directly. Right? So don't worry, if there are odd number of elements, then that will simply come here. And that may get merged sometime later. And one more thing. When I am merging them, where I am keeping the elements? They are not kept in the same array A. Definitely when you merge 2 lists, you need to store it in a third list, that is third array. So here I have 2 lists in a single array. So after merging, I need one more array B where I will be keeping this result. So remember that when you merge, the result has to be kept in a separate array. But I want the result in A only. Okay, copy it back from B to A. So if there is an array list, if there is an array A, then the elements are merged and we get the result in B. Then all these elements will copy them back to A. So again the lists are in A only. This is what we do. So I am not showing it here. Programmatically it can be done. Now I have 4 lists. I have to merge them. So 4 lists, I'll pick up 2. So 2 lists each with 2 elements. Merge these two. So the smaller is 3, the next is 5, the next is 7, the next is 9. So I have done merging. I got one list of 4 elements. Then merge these two. So 2 is the smallest, and then 4, then 6, then 8. Now I have 2 lists of 4 elements each. And I have completed one more pass, means I have gone through all the elements. So this is second pass. Now I have just 2 lists. I have to merge them and I get a single list now with 2 is the smallest, then 3, then 4, 5, 6, 7, 8, 9. That's it. Now I got a single sorted list. This was the third pass. That's it. Now the elements are sorted. Finally, you can keep these elements back in array A. So single array of 8 elements is sorted by using merge process, and that too we are using two-way merging. That is, we are merging 2 lists at a time. Now let us do some analysis. How much work is done in each pass? So I am merging n elements in this pass, and again merging n elements in this pass. So together total n elements are merged here. So actually 8 element, 8 is n here. How many times this is done? How many times it is done? 3 times. 8 elements, 3 times. So if you see this one, 8 elements were there, 8 lists were there. They are divided and we got 4. So they are divided by 2 and we got 4 lists. Again they are divided by 2, then we got 2 lists. Again that 2 is divided by 2, so we got 1 list. So finally this is 1. So how much this is? 8 is divided by 2 raised to 3, that is becoming 1 list. Finally we have stopped when it became 1 list. So this is 8 is equals to 2 power 3. So how many passes? 3 passes. 3 passes. So this is log 8 base 2, that is 3. So it means log of 8 gives me 3. So I can know the number of passes by taking log of that number of elements. So it means how many passes are required? Number of passes log n, whatever the number of elements are. Now in each pass n merges are there, and likewise log n passes are there. So total time is n into log n. Yes, I can take it as theta because there is a class available for this function n log n. So the time complexity for two-way merge sort is n log n. This is the working of two-way merge sort. Now, we have seen what is merging, and also we have seen how multiple lists can be merged together, that is in two-way merging or m-way merging we have seen. And if there are multiple lists, then we can merge them in different patterns. We have seen that. Now let us see merge sort, that is a recursive procedure. And this is divide and conquer procedure. The divide and conquer strategy says that if a problem is large, then break the problem into sub-problems, and if the problem becomes small, then solve it and combine the solutions of the small problems or sub-problems to get the solution for main problem. So here the problem is to sort these elements, and we say that the list is very large. Then what is small? So basically if there is a single element, then we say it's small. So single element means we don't have to sort it. So yes, in merge sort we say if there is just a single element, then we don't have to sort it. Otherwise, if there are two elements also, we have to call it as a bigger problem or large problem. If there is a single element, then we say it's a small problem. Merge sort follows divide and conquer, therefore it's a recursive algorithm. Let me write the algorithm, then I will trace the algorithm. Let us see. Algorithm merge sort. What are the parameters it takes? It takes two parameters, that is beginning of a list and ending of a list. So low and high. Then we check if low is less than high, means if low is equal to high, it means there is a single element. Low is less than high means at least there are two elements. So list is large. If low is less than high, then we will find out mid, that is low plus high by 2. What for we are finding mid? Like if I find 1 plus 8 by 2, that is 9 by 2, I get 4. So this will be mid. What for? We say that this problem is large, so we break it into two sub-problems. That's what we find mid. Then what to do with the left-hand side? Perform merge sort recursively. Perform merge sort on the right-hand side recursively. So perform mid, find out mid, and perform merge sort from low to mid. And also perform merge sort from mid plus 1 to high. So by performing merge sort on the left hand side, we will sort this one and we sort the right hand side. So when two lists are sorted, we are breaking this into two lists, and when two are sorted, we can merge them together. So perform merge. Merge from where? Low to mid is one list and mid plus 1 to high. So we pass three parameters. So that's all. This is a simple algorithm for merge sort. This is divide and conquer. How merging is done? We have already seen the procedure how merging is done. But the point here is, when the single array is given for sorting, we are breaking into two sub arrays and we are saying this is one first list and that is second list. So single array will be containing two lists and we have to merge them. So can a single array have more than one list? Yes, a single array can have many number of lists. Let us see how it works. Let us see the tracing. Now based on this algorithm only, I will do tracing. Initially we'll be passing low as 1 and high as 8. So let us take for these set of elements. So first time we will pass 1 and 8. it will find out mid and it will divide the list, and this side and that side. So mid is perform and perform merge sort from low to mid, that is from 1 to 4. It will go this side, and it has to go on the right hand side also, but not now, it will go afterwards, but I will draw this one also. So let us take this one. So it will call itself from 5 to 8 on the right hand side. So it has broken them into two lists, first part and the second part, and then afterwards merge. So first of all, let us finish this and this. Now merge sort calls itself low is less than high. Yes, 1 is less than 4. So again find out mid and call these two. So it means these 4 elements are also large. Divide them. So this side 1 to 2 and this side 3 to 4. Now when we take this, again low is less than high. Yes, there are 2 elements, so this is still large. Again split it. So 1 to 1 on this side and 2 to 2 on this side. Now there are just 1 elements. See, if you have seen previous video, you may know how two-way merge works, two-way merge sort works. See, if you have seen previous video, you know how two-way merge sort works. Now here also merge sort is working in a similar way. One array was given, so it has splitted and then splitted, then splitted. Now it has reached one element. Now one element is there means it's a single list with one element. Now these two can be merged together. 3 and 9 are merged together. So the first merging is done for these two elements and their result is obtained here. So this is the first merge done. This is the first merge done. It will merge these two elements. So 3 and 9 are merged. Then coming to this side, it will split them and get 3 3 on this side and 4 4 on this side. Then it will merge the elements. 3 and 4 are merged. So first 9 and 3 were merged. So the result was 3 9, and now 5 and 7 and 5 are merged. Result is 5 and 7. This is combined. Now it will go back and perform merge here. So this is the third merge. So it will merge these two. So the result is 3 5 7 9. Now this side is sorted. Actually we have to sort this whole array. Break it and break it and break it. Now 2 elements merge, 2 elements merge. Now merge these two also. So this side is sorted. Now same thing is done on the right hand side also. 5 to 8 is there. So on that side it will divide this from 5 to 6. And that side it will be 7 to 8. And 5 to 6 will become 5 comma 5 and 6 comma 6. Now 1 element each. This is again splitted, 1 element. So these two are merged. So it becomes 4 6. So this is the fourth merging. Then it will go this side. It will split again, 7 7 this side and 8 8 this side. So it will split this also. Then again these two are merged. So it becomes 2 8, one more list. So this is fifth merging. Now as these two are already sorted, it will merge these two. So it becomes 2 4 6 8. So this is sixth merging. And then these two lists are merged to get a single list, that is 2 3 4 5 6 7 8 9. This is single sorted list, that is seventh merge here. So this is how merge sort works. When a single array is given, recursively it will divide that array into smaller pieces until it reaches one element, then it will start merging them. So you can see that 8 elements were given, splitted, then splitted, then splitted. Now they are merged, merge, merge. So this is the working of merge sort. Alright, so it's similar to two-way, but in two-way merge sort, we just take first 2 elements, the next two, the next two. But this is divide and conquer, and this is recursive, so it will simply divide and divide, and then that's how it reaches one element, then it will start merging them. So what is different is only the pattern is changing, the approach, rest of the things are same, right? Result is sorted, and it is also merging two lists at a time, so it is also two-way. But as it is recursive, we need some another name, so we call it as merge sort. Let us see the time taken by merge sort. So from the tree, the recursion tree, that is the tracing of that algorithm I have done. So I'll show you how the time is, I will show you how much time it takes. See, the merging has started in this level. This was just splitting. So how many elements are merged here? Two elements merged, two elements. Total how many elements? 8 elements are there. 2, 4, 6, 8. 8 elements are merged here. So I will say n elements are merged, all n elements. Then again merging is done at this level. So 8 elements are merged. Then again 8 elements are merged here. So n elements are merged each time. So total how many levels are there? 1, 2, 3 or 1, 2, 3. So total 3 levels are there. So for 8 elements I got 3 levels. It means it is log of 8. Log of 8. 1 and then 2, then 4. So when something is raising by 2 every time, and this power of 2 lastly, power of 2, that is 3 at the last, we are having 8 elements total. So 3 is log of 8. So how many passes are there? So actually these are not passes because it is recursive. First it will enter this side, then it will go that side. So it is not passes, right? First it will finish left side, then right side. But levels if you see. So total how many levels? Log n levels are there. So this will be n, how many times? Log n times. So the time taken by merge sort is theta of n log n. That's it. So the time for this one is also n log n. Now taking these numbers, I'll show you how this merge sort works. Low and high are taken. So example is 1 and 8. 1 and 8. So let us see, using the numbers I'll show you. First of all, it will find out mid and it will call merge sort on the left hand side. So it will take these numbers and call 9, 3, 7, 5. Merge sort is called on this. Then now this is 1 to 4. 1 to 4. Again, this becomes 1 to 4. So this is the first call, right? First call. Then 1 to 4, the first recursive call. 1 to 4 is 1 is less than 4. So again it will call itself by finding mid, it will call itself. So again it will split. So this is 9 and 3. So just 1 and 2. 1 and 2. Then again this is also low is less than high. This is low and this is high. Just you can follow that one. Find out mid and split it. So 9 on this side. This is just 1 comma 1. And 3 on this side. Just it is 2 comma 2. Right? So it has called itself and itself and itself again. So this is one list, it has splitted, then again this is splitted, again this is splitted, and this side. Now these two are merged, so the result become what? 3, 9. Right? Then it will go on the right hand side, so this becomes 7, 5. That is 3, 4. Then it will come on the left hand side, this is just 7, 3. Then it is just 5. So these two are merged. So it becomes 5 and 7. Second call has finished. Now this side is completed, this side is completed. So what is the next step? Merge. So these two are merged. So this becomes what? First 3, then 5, then 7, then 9. So that's how it has splitted, then splitted, then splitted, then merged. So till here it got the result. Now it will go on to the right hand side. So this part, second part for this one. So this will be 6, 4, 8, 2, and this is from 5 to 8. This one. Now on this, 5 to 8. On this one it is called 5 is less than 8. Yes. Again find out mid and call merge sort. This one. So on the left hand side it will be called. So this will become 6, 4. It will be 5, 6. Indices are 5, 6. Then on this again merge sort is called. So 5 is less than 6. So again find mid and call merge sort. So it will become 6 and this is index 5. Now low is also 6, high is also 6. It will go on the right hand side. This call for this one. So this will be 4 and the index is 6. So low is also 6, high is also 6. Then merge. These two are merged. So it becomes 4 first. Sorry. Then it becomes 4 first, then 6. Then it will go on the right hand side of this one. So right hand side is 8 and 2. This is index 7 and 8. Now low is 7, high is 8. So low is less. Again find out mid and call this one. So this side it will be 8 and it will be 7. Now just one element. So go to the right side. 2, single element. Now merge. So left side completed, right side completed. Now merge. So 2, 8. It becomes 2, 8. Now this side, both are sorted. Merge. Both are sorted.